welcome back, guys. In this video we will be discussing about the implementation part of traversals in binary tree. I hope I'm clear. So traversals in binary tree, we have previously implemented the construction or implementation of this binary tree here. This was the root node as p, and that has left and right child as q as left and right as s, and so on. So we have implemented this. I hope that was clear to you here. So we have implemented this before and it was pretty clear how to do that. I am hoping that that's the case. So in this video, what we want to implement in order traversal, and then maybe pre-order traversal, right? Then post order, then level order, and maybe if there's enough time, we will also discuss the height of the tree here. That's here is the height is 3, so we'll try to make sure that we get that. First, in order, I don't know if in order, let's make sure that we have something to work with. Yeah, so in order is something like this. We go from Q, P and S, but from there to there, that would be inconvenient because there can be more left children here. I think we should start with post order, or no, we should start with pre-orders, right? Because we are on the node, we are on the P node. Usually we start from here, then we go from left, then we go to right. So pre-order would be the best choice here, because we are here, then we want to go left instantly, we want to go at left and then right. That's, I guess, the best case scenario here. So let's start with pre-order, right? The main thing is starting with something. We'll figure it out somehow. So what we want in pre-order, we just want to define a recursion. In this case, if the same scenario here, the same recursion here as displays this, as we did this, where the case will be similar to that. So we want pre-order here so that we can recurse here, right? But we want to pass here, we want to pass the root node. At least we should be here, right? So we want to pass the root node here, self dot root, and we also want to change the line here as well. Now this is pre-order, so let's make sure that we know this is pre-order inside the console as well. This is pre-order. I hope that's fine. Now we want to define that private function here. The private function is pre-order under root order, right? So self comma, what's the second first, that root. So what's the root? I think P, yeah, PHP, capital P. Now what we want is that we want to print the P information, whatever the node has, the node information that has. But if it does not have any information, in that case we don't want to return anything as usual. I guess that's understood by now. And if it's none, it's just waste of time. No, we don't need that. So we don't need to return anything. If we have something, we just need to print the information. p.info, that is capital, and that's amazing. That's amazing because we have printed this. Now we are here, we want to go here. Now we have to traverse to Q, then to S, right? So in this chart, at least in this binary tree, we want to go from Q to S, and we can repeat that for P for this tree as well, right? So first, let's make sure that we are traversing in this in this one. So we can do that by using the recursion method as we discussed. So how we can call that recursion? Some recursion is right. So that's all we have to do now. The root node has changed. The root node is now Q. Am I right? So what is Q? Q is P dot left children of the P dot P left child of the, I'm guessing left. So P dot left child of this, and if we have something here, it's same dot right. So I hope that's clear. We are here, then we got here. If this is the left child, then we got here, and the right child. Now what we will do, we will just repeat the recursion for this tree and so on if there are any more trees. So it will just repeat itself or recurse itself again and again. This program will just recurse itself. I hope that's all we need to do, and we are going to try that. That's the output. So do we have any error? We don't have any error. So let's just make sure that we call the function now. Why are we running this code beforehand? Because we already need to change that. There is so it's printing, but it's not in the way that we wanted. First of all, we need this end equals to nothing at all. I don't like that. And we also want this end to be proper, right? This end is not proper. This is changing lines. We don't want that. We want the tab. I forgot a comma there. I hope that's pretty much that. And in 7 minutes already we have, I am hoping we have the pre-order of P. Yes, we have the yeah. So I am guessing that you understand pre-order, and this is the result that we wanted. P, then Q, then T, then U, then S. Alright, so I'm hoping that you understand that this is what we wanted all along. Now we are clear about that. Now all we have to do is, this is pre-order, okay, for the commenting part, and we will just copy that. Now copying control of the right. So all we have to do now is that we have planned a recursion, right? We are recursing through nodes. What we can do now, we can start from here. We can start from left child, then go to root, then go to the right child. That's really simple. I guess there is not much to explain there. So that's in order, right? That's in order. So let's change that to in order, and in order as well. Now this function is in order. There are a lot of in orders here. So yeah, recursion through in order only. So what's the change that we want? What's the change? The recursion must start from left, not the right one. There must be this. So that's all, guys. I guess that's gonna work. So let's try first, right? PQRS, and we need to call that binary tree. Okay, amazing. So control S, no errors, and as well, yeah, amazing. So we were here, guys, and we first got into the function, we got into the recursion here. At this line, what happened was we got here, right? Then recursion was called, so as well the p is not empty. Then again this was called, so we went from here to here at t. So t was printed, so because after that the return statement is there, because there is no left node, so t was printed. Then we got at the return statement, the return statement got us here. Then we were at u, the print information was there, so we printed the q. Then we got at right, because this was what we have, so we got here. Then we got up, returning from here to the root node, that root node is here, and then we got from that, we got there. That's amazing, we can do that to post order as well, right? Let's try that, why not? So this is amazing, this is the ace of programming, guys. This is so simple for us. If we do that, I'm guessing all we have to do is change that post, and voila, that's all. So I hope I don't mess that, at least. Post. Amazing. So all we have to do now is that we want to access this root node at the end, right? That's all that is changing. So root node, first left, then right, then we're going to get that root node information at the end. That's all, I guess. I am hoping I'm not missing anything. Okay, this has to be changed. Oh, capitalization, that's my old habit. I'm sorry about that. So yeah, that's all, I guess. So alright, do I do that? Control, yeah. There are some very good features in VS Code, right? Let's use those. Control S and let's run this code. STU. So yeah, T, then U, then Q, T, then U, then Q, then Q, then S, then P, then Q, then S, then P. That's amazing, guys. This is what we wanted. This is the post order of the tree that we are looking at. Now comes the part where level order traversing comes in. Now that's also going to be easy, I'm hoping. Let's just try that. For level order, I think we should know about the queue. Queue is one thing that we will be using, so let's do that and add that to our program. If you don't know what queue is, that's a type of data collection, data type that we use for data collection. Let me just import dq, the library that we will be using. So yeah, we will use dq for queue data structure here. I won't go into the details, of course, because this is covered in, it will be covered at least. I'll provide the all the necessary details in the description as well. So queue, we will be using that. Now what we want is that we are going to store the whole this whole thing into one. Then we are going to traverse like queue, that this whole thing is actually going to be stored at some point. I'm not gonna store the whole, I'm gonna pop those out. Pop the left one, yes, left one would be popped. So as soon as we go here, and as soon as we get a whole level, we are going to pop the P, then Q, then S, the left hand side of the Q. So it will be like something like P, then Q. Then we want to add that whole of that tree, right? But we want to also add s, then t, then u. That's what we want, right? That is what we want. I hope yeah, that's possible. That's possible. Of course it's possible. It's done already. What I'm talking about, level order. So we wanted a queue and we have that level order. We are going to self, and we want that if root is self or root is empty, equals to none, then we don't want to return anything. That's a statement, I guess I'm making a lot of time. So but we want a queue. I'm just gonna take that as a queue as well. So the queue, we have queue. So what we want to append in that, we want to append the p, this one, right? So what is that? What is that? Dot p? No, the information is q. So let's append. If you don't know about the append function, that's also something you should be searching about right about now. So we want the root here, right? We want the root. We have the root. Now what we want, that this here, this must be forming somewhere. Now when will that last? While something is inside that. Something is inside that. That means that length of q is not equals to 0. So there is something inside it. The length is not 0. So we have something inside it, right? So length is not 0. While that's the case, all we need to do is we want to pop it out. Pop the left one. So we want to pop the q here. So we can do that by using the pop left. That's amazing library. Print. Let's print the. So we have the root here, and we want to print. Oh yeah, this is the root, right? So we have p dot info. It's inside that info. We have information in this p circle, right? So it's p inside p. So p plus, I guess. Do we need the information? No, we don't need that. I guess we don't need to use the concatenation here. So if there is p left, then we need to print it. If there is no printing, if it's not none at least, then we need to append that, the left hand side of that. So p dot left, right? So we want that whenever I come here, I want to append this as well. I want to print it and then go here to append that inside this queue here, right? So whenever I come here, I want to append this queue as well, so that this condition does not become true. Okay, that's simple, I guess. Simply done. Now what we also want to append the left hand side as well. So as we are here, we are accessing this, and might as well add this one, right? So if p dot right is not none. If you don't know why we are not it should not be none before adding it, because if does not has any information, we just want to return it. For example, q here does not have a left child, so we just want to return. That's why we are using this not none function a lot of times. I hope you are understanding that point at this point of the video, I guess. And we want to p dot right, p dot right. That's all. That's all. So I think that's all we need. We have the Q. Q. Is there any errors? Let's take a look there and just let's just level order self. I am getting a good vibe out of this, and I can't see any errors at least. That's all. Oh, sorry, I didn't say that. Yes, we have error though. Oh, collection. It's actually not collection. Where is collection? I'm hoping that's not the error that we are going to get. So it's PQSTU, right? Yes, that's amazing. PQSTU. Level order traversing completed. This is the part where you want to print it something like the, if you want to print it like this, you can do that. All you have to remember is that star, one star at a time. Let's take, for example, one star, then two stars, then three stars. That's all you need to know. If you know this program, then you can also use that to print the binary tree like that. If you don't know, I'll just cover it. Don't worry about it. That's amazing. That's amazing. So what do we have here? What we are printing? When we are printing that, let's make sure that and is not. Where did I print that? I don't know where did I print it? Upload left print information. Yes, here it is. What the hell? You were hiding from me, huh? Don't worry, I'll just make sure that you have it. Now, this is it, and we need that as well. Let's. So this is level order. That's all. That's amazing. That's amazing, guys. So we have successfully implemented this as well. Now we have almost let's take a 3-minute class or 4-minute class for the height as well, right? Let's cover that while we are at it. This will be not an issue because I am pretty much sure that all we have to do is check for any right or left node. If it's not that big of a deal now, but if the left node has, for example, we don't have this, then we need this. So if it has height, so yeah, that's possible. Let's say that this is the binary tree and we have a left child and a right child, so the height becomes 2, right? 1 plus 1. But if there is no right child, then the height remains same because the left hand side has a height of 2, P and Q, 1, 2, and right hand side has a height of 1, 1, 0. So only 1. Here we have 1 here and we have 2 here. So what will be the answer? The answer will be 2. That is because the 2 is bigger than left hand side. All we have to check is that if H left or H right, which one of them is bigger. So let's try that. HG. That's amazing. Self. I'm using the recursion method here again. That's pretty much very simple, and if I am doing any errors, please comment it out, right? I'm sorry. Actually, this video got lengthier than I thought, and that's not what you want, right? This is getting boring for you, I guess. You just want the implementation. So we'll just make sure you have it. So height, how we are going to use the recursion? The same old method, self.root. We are passing the root here and we are defining it now. Define HIGHT So so whichever the node is, don't be, we have defined that, right? So if I'll just copy that. Here we have it. I'm sorry for taking so much of your time, guys. I know this is, I'm trying my best, guys. Here I'm making it as soon as possible. This is just like competitive right now. I don't know. Maybe there can be some errors now because I am in a hurry now. So we have to just recurse through height. That's all right. We have to recurse through height, but we also need that left key. We are recursing through height. So that's all. So this is the left hand side height. So I'm actually trying to get that left hand as deep as I can possibly grow. So I'll just copy that for the right one as well. What the hell just happened? Right. Okay, right. RIGHT right. Okay. So we have both the let's say we have both the heights now. So whatever the bigger one is, we will just print that one. So I am just close to that. Now returning. Now okay, now we have this. Now we want else if that's the case. So equals to, we don't have to manage the equals to part, or because if it's equal, it will just go for right one and it's same, right? So we have actually done everything that we could. Now is there any errors? I don't think so, right? I don't think so. So control shift S, and we are going for height. Actually we need to print it. I'm returning the statements there. I hope that's gonna work right. Let's see, there is an error. Module print retreat or out. K-ary has no it. I thought slash height. Did a spelling mistake. Okay. We are actually comparing the non-type with the non-type. Okay, that got. Oh, okay. It's actually at the end of the recursion. So I will just leave that to you guys to understand, I guess. Non-type to non-type is the error. We are actually doing this right. B.left, I'll just pause the video for you guys. So there was actually no error. It is did not save that. You can return 0 there, and yeah, that's all. I just needed to save it. That's all, guys. That's all there is to it. So don't worry, the code is working. The implementation is perfect. I don't guess there is anything I can do in that extra, I mean. So we have successfully implemented all the traversals. We have also printed the height of the list successfully, and here we have the height. Right. So yeah, that's all. We are printing the height as well, right? So that's all, guys, from my side, and thank you for the time. I hope you enjoyed the video, and you can tweak this code as you want, and I'll just leave it to you guys in the GitHub. That's all, guys. Thank you so much, and enjoy the videos. Tata.